The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. I'm John Torres, Solutions Sales Executive for QueBIT, and on behalf of our team, we thank you all for taking the time to attend today's presentation. I will highlight how our customers leverage IBM's advanced analytics technology and QueBIT's related subject matter expertise to help them better detect fraudulent activities, proactively prevent them from occurring in the first place, and gain tangible financial returns from doing so. For those of you who aren't familiar with QueBIT, we are a long-standing IBM business partner that's focused on their business analytics software solutions, which include Cognos BI for enterprise reporting and data visualization, TM1 Performance Management for financial planning and analysis, in addition to some complementary add-on products that we've also developed, and SPSS Advanced Analytics for Predictive and Prescriptive Business Solutions, which will be the focus of today's presentation. In addition to reselling, implementing, training, and supporting all of these technologies, QueBIT also provides consulting on best practices for a range of solution areas, including profitability analysis, workforce planning, and demand forecasting. And our industry expertise ranges across retail, CPG, financial services, and insurance, among other sectors. QueBIT is extremely proud to have been recently announced by IBM as their 2013 Worldwide Partner of the Year for Business Analytics Excellence. Today's presenter is Scott Muchler, QueBIT's Vice President of Advanced Analytics Services, who has a long track record of leveraging SPSS solutions to deliver significant business value. Like myself, Scott is a former IBMer, and he has worked with SPSS clients around the world architecting solutions for some of the world's largest retailers and manufacturers, as well as the solution for insurance fraud detection that he will present shortly. Scott is also a co-author, along with QueBIT's General Manager of Advanced Analytics, Keith McCormick, of the just-released IBM SPSS Modeler Cookbook, which speaks to the depth of experience that QueBIT brings to this invaluable subject area. While the specific use case highlighted in today's session centers around detecting insurance claims fraud, both opportunistic and organized, please know that the underlying technology platform and advanced analytics methodologies that Scott will be speaking about can also be leveraged by other types of companies to detect and avoid other types of fraudulent activity. Scott's presentation will span about 40 minutes, after which each attendee will have the opportunity to type questions via the chat box, which I will then read aloud, and Scott will answer as many of them as time permits. And with that, I'll turn it over to Scott.
Thanks, John. I'd like to start today's discussion talking about the broad value proposition for advanced analytics within insurance. We're going to focus on the first item here, which is claims fraud, which is identifying claims that are likely to be fraudulent, and equally as important, which claims have a low risk for fraud and can be fast-tracked. Also, there's the application for vendor fraud, which is more along the lines of organized fraud. And in underwriting, predictive analytics and prescriptive analytics can be used to improve the straight-through process by better assessing risk through data mining algorithms. In the subrogation process, advanced analytics can be used to identify claims that should be reviewed for possible subrogation. And then, like in most organizations, advanced analytics plays a major role in marketing in understanding which products customers are likely to purchase and which offers are likely to respond to. The business opportunity for claims fraud starts out with understanding that this is a highly scalable process where we need to be able to examine tens of thousands of claims on a recurring basis, looking for fraud with limited examiner resources. We also need to be able to leverage large volumes of free-form text, things like police reports and examiner notes. And we also need to be able to identify organized fraud, which historically has been very difficult to identify. With looking at just individual claims, you really need to look at things more holistically. We also want to talk about how do we leverage existing business rules along with predictive models so that we can leverage our existing business rules if they exist. And we also want to focus on, in the solution, how do we find fraud early in the process to mitigate those payouts to fraudulent claims. So you can see it's a substantial business opportunity that has a lot of technical challenges, and we're going to try and address those today with our solution. Looking at the solution, the QueBIT Advanced Analytics Fraud Solution, from the high level here, you can see this flow that we have. We start with our open claims and we run them through two separate processes. The one on the left is we're looking at business rules, whether those be NICB rules, internal rules, and we are looking for fraud features at the claims level and assigning risk points to each fraud feature. We sum up all those risk points, and a higher fraud score would equate a higher risk of fraud at the claim level. From that, we can generate a recommended action. So in this particular example, it had a low fraud score of 7, and the rules represent or actually recommending no action. On the right-hand side, you can see the other path that we take with our open claims, which is to run them through a predictive model. And we'll talk about how these predictive models are built in a minute here, but just understand that the output of a predictive model is at the claim level is a propensity for fraud. So this particular claim, actually, the model is saying there's an 89% chance that this claim is fraudulent. And the action coming out of the predictive side of this equation is to refer this for further review. So as you can see, we have conflicting recommendations here, which doesn't often happen, but it does happen, so I want to bring that up. So we need to be able to have a rules arbitration process to say, well, we have conflicting information here, so what do we do? And from that rules arbitration, we end up with an optimal action. So at the top, we have open claims being processed, tens of thousands of them on a frequent basis. At the bottom, at the claim level, we have, for each of those claims, we have an optimal action to take, whether that's to fast-track the claim, to not spend any time on it at all, or it's to refer it for further examination because we see indications of risk for fraud, or to take the normal processing. So let's take a look at some business rules. We'll start out with an NICB rule. The rule is, so the NICB are national rules that are industry standards for detecting fraud. In this particular example, we're looking at personal injury fraud. And so in this rule, it says, despite expensive damage claims, the claimant vehicle remains drivable. So let's look at how we determine whether that rule applies or not applies to a specific claim. So we start out with the police report, and the police report has a statement that says the driver was able to drive home without assistance. Through the use of text analytics, which we'll talk about here in depth in a minute, we're able to take that information and turn it into structured variables at the claim level that say that there was no tow, so no tow equals true, and there was a minor injury, it was equal to true. We have other structured data like the appraisal for the vehicle damage and the medical bills. And so as you can see, if we set limits on these and we say that if they have this minor damage with the major medical based off the structured data, we would give 10 risk points to this particular claim. So that's an example of an industry standard rule. We also have the possibility of having internal rules. So claims where the claimant has a prior claim are at a higher risk of being fraudulent. So we have 3 claims here, one by Susan Smith, one by Susan Palmer, and one by Susie Smith. Through the use of entity analytics, we were able to identify that that's actually the same person, even though she gives different information for each of the claims. We identify that as Susan Smith at 123 Elm Street, and we identify now that she has 2 prior claims. From that, we can deduct that yes, this rule does apply, and it now has there's now 15 additional risk points. So we sum those up for this claim, and we end up having 25 risk points. And based off of our rules, that may or may not recommend a particular workflow for this claim. So just a little bit of a deeper discussion about text analytics. So text analytics is an extremely powerful tool and has a great application here within insurance, in that we can look at this unstructured text, and there's lots of unstructured text in insurance. There's police reports, there's examiner notes, there's medical forms, there's just a wealth of unstructured text. And by running it through this text analytics process, we can turn that into structured data. So down at the bottom, you see an example of vehicle driver claims accident was not his fault, vehicle was has dented bumper, vehicle was still drivable, vehicle driver complains of sore neck but was able to drive vehicle home. By looking at natural language processing, we're able to take that and turn that into 3 structured variables. So the first is that the driver denies responsibility, that it was a minor damage, and that it was minor injury. So as you can see through this process, which is highly automated, you can take data which was largely unavailable and unusable by both rules and predictive models, and now we can actually use them directly within our modeling process and our rules process. Entity analytics, which is a relatively new technology, is also extremely exciting for insurance. And the idea behind entity analytics is that often you will get information about persons or organizations that they appear to be different entities, but if you look at them a little closer, they're actually the same entity. And the reason that they can be ambiguous is for a couple of reasons. One, it can be totally benign in that the person has changed their last name through marriage. They did not give you the correct Social Security number. The data was incorrectly typed in, or it could be for reasons of trying to perpetrate fraud. So you may have vendors that try to hide their identity by billing through multiple locations. And the idea with entity analytics is to create a web of information about these entities and to bring them together. So in this example, we have Beth Parker, and we have Liz Johns and Elizabeth Lisa Johns. And if you look at the data, there's no single piece of information there that is replicated across each of these records. But there's this web of information that can be fuzzy matched together, that can be joined together to resolve those 3 entities into a single entity. And this is a configurable system. You can define what the rules are. There are templates, but you can define what the rules are and how loosely it has to match. And at the end of it, what you end up with is, instead of 3 separate claims from 3 separate people, you find out that these are 3 claims from the same person, which is incredibly valuable information. And on the organized side, you can identify vendors that may be billing through 10 different shill organizations that actually are the same vendor. So incredibly valuable. Next, when we talk about organized fraud, which is notoriously difficult to identify, we use a technique of what we call fraud neighborhoods. And the idea is to connect vendors and claims together through relationships. And those relationships can be addresses, DBA names, incorporator names, telephone numbers, shared claims, and we create these linkages, and we sort of do the 6 steps from Kevin Bacon thing, where we look at a vendor that we don't know whether they're fraudulent or not, or a claim that we don't know is fraudulent or not, and we look at how many steps does it take for us to get to a suspect vendor or a suspect claim. So in the first example there, you can see that this vendor 1253 is actually connected to 2 suspect vendors from our watch list, and in one circumstance it's 1 step away through a shared claim, and in another step it's 2 steps away through 2 shared claims. And ultimately we end up with a data set that is much more manageable by the analytics. And in the analytics we essentially look at the number of shared links that we have at a direct linkage, 2 steps away, 3 steps away, and then we add on additional information like the number of times that the vendor has billed through a PO box, the number of distinct billing locations, and it's very easy then at this point, once you get the data into this format, to differentiate between what is a vendor that has a clean record and what is one that is in a very tight neighborhood of fraud. Okay, so now that we've discussed how we sort of pre-process the data. We run text analytics, we run entity analytics, we look for these fraud linkages. I want to show you what an example of an input data set is. Now this is somewhat abbreviated from what a real data set would look like. But what we have here in the blue is we have our basic claim information, and each of these columns represents a claim. And then in the green we have this sort of derived information that is taken from both text analytics and entity analytics. So as you see this number 2 here with previous claims, that would come from entity analytics, having identified a person as having multiple identities being resolved down to 1. And then these minor damage indicator, minor injury indicator, and no-tow, those come from text analytics from the police reports. And so you can see we can create a very rich appended data set at the claim level. And then very importantly down at the bottom we have historical cases of whether we've identified fraud or not. So If there's a 0 there, that represents that this was a non-fraudulent claim, and if it was a 1, it was a fraudulent claim. So on a historical basis, we've gone back and we've identified this fraud or non-fraud. So now we have this training data set excuse me, that we can use to train our predictive models and actually use in our rules. So how does predictive modeling work? A lot of people think of it as a bit of magic, but it's actually quite simple if you think about it. We give the computer data around fraudulent and non-fraudulent claims. And we say, look at the fraudulent claims and the non-fraudulent claims, look at all the data you have, and can you identify patterns or mathematical relationships that help you predict for any given claim whether or not it falls into which group, into the fraudulent or the non-fraudulent. So we use these fancy statistical algorithms and artificial intelligence algorithms. Typically we use neural networks and logistic regression and decision trees, but ultimately they all do the same thing. Look for patterns in the data that indicate fraud. And the final output is a predictive model that if you give it a new claim or even an existing claim, it will tell you what the likelihood of fraud is. Now at this point I'd like to mention that in the previous example we knew historical fraud. We knew whether there was fraud or not. That's when we would create something called a supervised model. That's the most powerful kind of model. It's the most accurate kind of model, but it's not always possible to do that because sometimes you haven't identified historical fraud. So we can create a second type of model where we haven't identified fraud, and that's called an anomaly model. So either way, we'll be able to create a predictive model. The issue with anomaly models is they tend to create more false positives, but they can then later be turned into supervised models once you have gone back and closed the loop with the examiners and said, okay, the examiners looked at these 10 claims, these 3 were fraudulent, so we're going to feed that data back into the system, and then we'll be able to create a supervised model going forward. So you don't have to necessarily have identified historical fraud. Now, the predictive fraud modeling piece of it, where we're inside of our modeling tool, which in this example we're using SPSS Modeler, is actually the fun part for us modelers, but it's actually a very short period in the entire project. Once we have the data and getting it in the right format, that's a significant amount of the work. But what we do is we now take these historical claims, we run them through these algorithms, and we get some really interesting outputs from it. We get rules that come out of it. You can see in the lower left here that can be used to refine our business rules. We also get in the lower right, we get information about which variables are important indicators for fraud. We also get information about interactions, which variables have to occur together for fraud to be indicated. But ultimately at the end we end up with this very important gold nugget that you see up here in the upper left. And that gold nugget is our mathematical model that can now take new claims, you feed it through that model, and it will now come back and tell you what the likelihood of fraud is. And the nice thing about the model is that it can score millions of claims literally in minutes. Once you've built the model, the actual scoring of it is incredibly fast and incredibly scalable. One of the side effects of building the model is we can go back and look at historical claims, and we can create this interesting looking chart here. It's called a gains chart. And what it does is it says how much better does the model do than just randomly picking a claim and examining it. So the red line represents randomly picking it, and the light blue line represents how much better the model is than randomly picking. So if you follow the blue line at the bottom here, the arrow, at 20% of the claims, if you pick the top 20 highest risk claims according to the model, you would have identified 80% of the overall fraud. If you go to the 40% of the highest ranked claims based off of the model, you get to almost 100% of the fraud. So the way that I like to interpret this is, the difference between that blue line and the red line is the value you're getting out of the model. It's the efficiency now that you're putting into your process, and it's the time you're giving back to your fraud examiners that they can be spending diving deeper into the high-risk claims instead of looking at claims that really shouldn't have been looked at in the first place. Now, once we have defined all of our business rules, we can now build the solution out, and this initially QueBIT comes in and we help you build this out, but this is something that you can manage, your claims team can manage going forward, add new rules, change the model, change thresholds, and have total control over the process. So in the upper left, you'll see that we have personal injury and property damage as two separate areas. Within personal injury, we've defined three actions: refer for examination, our default processing, and fast track. In the upper middle section, you'll see our business rules, and each of the business rules has risk points associated with it, which we discussed. Here's a look at what those rules look like in more detail. You can have them just specified based off of value. So if the appraisal amount is less than $2,500, or the minor damage indicator is true, or the minor injury indicator is true, and the medical bills are greater than $3,000. Now this is a simple, straightforward business rules. You can actually have business rules that are mixed with predictive models, and you can get some very sophisticated, complex looks at this. But this is a very straightforward business rule, and then the risk points are sort of initially populated based off of business experience, but can be tweaked later on. And then based off of that, we then set thresholds here in the middle. And we say that if there's negative 25 to 5 points, that's a fast track. If there's 5 to 15 points, that's default processing. If there's greater than 15, that's sent for referral. And that essentially completely configures the rules portion of it. Additionally, we can also include the predictive model. So the predictive model in this case was handcrafted by QueBIT, but you can actually build the model interactively here. You just tell it what the inputs are, and it will build it all for you automatically. In this case, we use a handcrafted model. Down at the bottom, you have your last little piece of information, which is your propensity. So if the propensity is between 0 and 0.1, we fast track. If it's between 0.1 and 0.5, it's a default, and if it's greater than 0.5, we refer it for examiner review. So as you can see, it's very user-friendly. You can come in here and modify this at any time. If you find out that you're getting too many hits on a particular rule, you can come in and tweak the values. So to go to that point, you can take your existing claims base and run a simulation against the claims base and see which particular rules are being triggered at the claim level. So in this particular one, the one that's being triggered the most is that all of the claimants go to the same doctor. So that's that bar over to the right. 87 of the claims actually had that rule being triggered. Additionally, you can also look at the differences between what the model tells you, the predictive model, and what the rules are telling you. So if you compare the left-hand chart here in the bottom right, you'll see what the model is saying. And the model is sending 616 through fast track, 200 that are being referred. But if you compare that to the rules are sending less through fast track and sending less through referral. So you see there's a little bit of disagreement here. And so this is where we need to set that arbitration. So I apologize, I know the font here is a little small, but conceptually what we're trying to do here is if we set up an arbitration scheme. So if both of the models and the rules agree that it's a fast track, we fast track. But if either of them say that it's a referral, regardless of what the other says, we're going to refer it for review, and then everything else is left to default processing. So what I would consider this to be is the most pessimistic type of approach, where you have to have absolute agreement on fast tracks, but if there's any indication that it needs to be referred, then we go ahead and refer it. Again, this can be changed, and simulations can be run against your existing claims base to determine whether or not you need to tweak this, this arbitration scheme. Okay, so here's the fun part. So now we get to what is the output of this entire process. So again, we start with the blue information, which is the claims information. That was the same as the input. We have the green information, which is the appended information. And now at the bottom we have the orange information. The orange information is the output of the model. So the first thing we get is the model propensity. So you can see the first claim is a 0.1, so very low propensity, whereas the second claim has an 89.5% risk associated with it, which is much higher. Then we have a model recommended action for what the predictive model is saying to do. They kind of follow. It's a fast track and a refer. And then we have the rules total, which is what the sum of all of the business rules are. So you can see there's pretty good agreement there that the high-risk one actually had 15 rules point and the low-risk one had 0 points. So we're getting good agreement there. The rules triggered is interesting. So what this is it's every business rule that's triggered separated by a pipe delimiter. That way your examiners, while looking at each claim, can know exactly which rules were triggered on each claim so that they can then know where to dig deeper. And then we end up with our final arbitrated overall action. So the first claim is a fast track because it got perfect agreement. The second is a refer because it got perfect agreement. And you can see for the rest of these that it comes up with our final recommendations. Now in this particular example, it was pretty simple. We only had 3 actions. But you can actually have much more sophisticated workflow. And you can refer them to specific groups. We're just keeping it simple for purposes here of demonstration. Now, in addition to that simple Excel view, we also have built a standard set of BI reports. In this example, we're using Cognos, but we can actually build these in other systems. And what we want to do here is we want the examiners to be able to look at, slice and dice the claims based off of fraud and actions so that they can spot bigger trends. So in this particular example, we're looking at zip code, and we're looking at the intersection of zip code with referral action. And so in zip code 10301, we see that 31% of our claims are actually being referred. And you can identify hotspots and identify particular areas that you need to look at. It may indicate organized fraud, or it may indicate some type of broken process. But essentially, it's very nice because you can sort of look at this through different lenses. You can look by fraud feature, by location, by action. It's a really nice way to view. And then ultimately, you can drill through and look at the individual claims and get down to the claim level detail. But this is a really powerful tool for the examiners to kind of give them that intelligence they need to quickly process these claims. Okay, so how do we deploy this? Deployment is really important with this because what we're trying to do is we're trying to streamline your processes within your claims team. We want you to be able to focus on only the claims you need to focus on, and we need you to get that information early in the claim lifecycle, and you need to get it often. So to that end, there's 2 different ways that you can deploy the solution. One is on a scheduled basis. That's monthly, weekly, daily, or even hourly. You could do it every 15 minutes if you wanted to. You run through all the open claims. Now, why would you run through all the open claims if you've already looked at claims? Well, new information could come in. You might get a police report. You might get an additional medical bill. You might get additional information coming in. So you want to constantly be reevaluating a claim. What might have looked like it was not fraudulent yesterday may now look like it's definitely fraudulent. So we're constantly reprocessing. We push the results directly to the database and or the BI platform so the reports are updated automatically. Or we can integrate with existing claim systems. Now, there's some level of integration that's currently being worked on that would be easier than others, but all of it's going to require some type of a short-term engagement to get that integration working. If you have a homegrown system, we obviously would need to develop something. If you have a commercial off-the-shelf system, there's some level of integration which may already exist. We would have to do that on a case-by-case basis. Now, in addition to scheduled, you can also deploy the system real-time, and this is when it gets really exciting. So imagine this scenario where you have a call taker who takes a call for a claim. They start typing in notes, and they pull up the claimant's information. They pull up their past history. All that data gets fed off to the QueBIT fraud solution, and the fraud solution comes back and says, there's a real high probability that this is a fraudulent claim. Here's the 3 questions I want you to ask for follow-up so that we can get additional information on this. That is really the ultimate kind of solution, because not only are you detecting it early on, but you're asking the right questions and you're giving real actionable information right at the point of taking the call. How do we calculate ROI? ROI at a basic level is pretty straightforward. And this is sort of the basic formula that we do, is we take the number of open claims, we take our detection rate that we've been able to take from the predictive models. We'll have a very solid number here. We'll know that we can detect 87% of fraudulent claims. We'll subtract the detection rate for your current process, if you have a current process, and then we'll multiply that times the average claim payout. So essentially what we're doing is we're calculating the number of fraudulent claims that we would detect over your processes, and then we're looking at the money we would save by shutting them down early. And typically we're trying to find fraud within the first 30 days and prevent those greater than 30-day payouts. Now sometimes we can detect it in the first week or the first day. Sometimes we can't detect it until 30 days in because it all depends on when the data becomes available. But our average, this is pretty exciting, our average year one ROI is 50x. So whatever it costs to implement the solution, you're going to get that back 50 times. That's our average return rate. We've had some pretty successful implementations, and we have had some pretty happy customers as a result of these large ROIs. So just as a sort of a sum up here on the particular benefits, this is a fully automated solution that supports real-time decision making. It redirects examiners to focus on high-risk claims while fast-tracking low-risk claims. So it's all about creating efficiency within your claims organization. You have a limited number of people that can look at claims. You have a lot of claims. We direct you to the ones you should really be looking at. It utilizes unstructured data that may or may not have been usable in the past. Certainly it's probably not been usable by the computer, but now it's definitely going to be usable in that way. It incorporates identity resolution and management through the entity analytics. It allows existing business rules to be merged together with the predictive models. And just a note on this, so we can definitely go in and build a model that has no business rules. So why do we recommend business rules being incorporated also? There's a couple of reasons. One is because there may be business rules that are purely about the way that you run your business, have nothing to do with whether it's fraudulent or non-fraudulent. You may always want to look at claims if they're over $100,000. You may always want to do that. Well, the predictive model is not going to be able to handle that because it's not really a fraud issue. The other is that it really helps the business buy into the whole process because they feel like this is not some magic black box. It's really a combination of what humans do well and what computers do well brought together. And then additionally, the last two things are probably the most important. The one is we typically find fraud much earlier in the life cycle than examiners. Examiners don't normally get looped in to look at claims until there's already been significant payouts, in which case it may be too late to recover any funds. We typically find fraud much earlier in the process and shut them down much more quickly. And of course, an average year one ROI of 50x is pretty exciting. If you'd like to learn more about the solution, I would recommend you go to our website. We have an insurance case study that goes into detail about a recent implementation. We have an executive brief, which is a PDF on advanced analytics for insurance that talks about all the areas of insurance, not just claims fraud. We have a video that replicates, maybe goes a little bit deeper, a little slightly different angle on what we talked about today. At this point, I would like to turn it over for questions. Hopefully we've left enough time here, and I'm looking forward to hearing your questions. Thanks.
Okay, thanks very much. Actually, we're running a little ahead of schedule, so if we have an opportunity to give time back, obviously we will. A couple questions did come in. One was actually a two-stage question, so I'll give you the first one up front. The first one is to define rules.
Okay. Well, the definition of a rule can be either something where it could be something that's particular to the way your company does business. So, like I said, always looking at claims that are greater than $100,000, or it could be an NICB crime rule. Essentially, what they are is if you're looking at data elements at the claim and you're trying to determine which fraudulent and what's not fraudulent, a rule might say, if these three things are true, then that's going to indicate fraud. So that would be an example of a rule.
Okay, great. And the follow-up to that was the attendee wanted to get an idea of, for this particular solution that you presented, which elements of the SPSS platform did you need to leverage? For instance, modeler, collaboration and deployment services, and so forth.
Yeah, that's a good question. So this particular solution uses everything. Is modeler client to build the models, modeler server to run the models, collaboration and deployment is sort of the repository and the automation engine for doing the nightly scoring or the real-time scoring, and then decision management is the piece that actually does the rules arbitration and sort of brings it all together. So it actually represents the entire stack from SPSS in the modeler framework.
And this question wasn't asked, Scott, but just as a follow-on to that, the charts that you showed, the PowerPoint slide, were those produced from SPSS?
The BI reporting.
Yes.
Yes. So the BI reporting was from Cognos Insight. Obviously, that would be, we would love to do it with Cognos because there's direct connection with Cognos, but we can rebuild those reports in any BI system.
Okay, great. Thanks. Another question that came through was, have you seen any negative impact on CSI scores as a result of false positives, cycle time increases, etc.?
What we've actually seen is that we are the most recent implementation we had, we found that we were far more accurate, and so every possible metric went up. We were more accurate in detecting it earlier, more accurate in detecting it period, and there was almost universal agreement that when we found fraud that the examiners were in complete agreement. So actually we have not seen any negative impact to any measurable metrics. I think that the reason why that's true is a couple of things. One is that we look at more types of data, and we can look at things at a whole different scale than what an examiner typically can. Some of the feedback we recently got was, this is really cool because you're looking at connections to other vendors and other claims that we couldn't possibly be able to visualize or see. And I think that additional breadth and depth of data that we look at has made it incredibly successful and incredibly accurate. So I guess to make a quick answer here is we haven't seen any negative impacts on those metrics.
Okay, thanks. Another question is, has this solution been checked for reliability and validity? For instance, can it be challenged in court?
So that's a really good question. And so the one thing about this solution is that it does, the way that we've always thought about this is we are essentially facilitating the process of examining claims. We're not saying a claim is fraudulent or not fraudulent in a legal sense. We are essentially directing examiners have the final say, and a human always makes that final decision about whether or not it's something that's going to trigger an independent medical exam, or it's going to trigger an examination under oath, or so really what we're doing is we're essentially giving information to the examiners, and they're ultimately making the final decision. So in that way, it's sort of one step away from that legal question.
Okay, great. Another question was for companies like insurers that already have some predictive fraud systems in place, how can this SPSS solution add value?
I think the key differentiators here are the ability to access the unstructured data, the ability to detect organized fraud, especially through the entity resolution, and the use of the predictive models. So the predictive models have a lot of great features. One of them is it removes bias, and it's very data-driven and factual-driven versus, as humans, we tend to get focused on looking at one or two specific facets, whereas this is looking at everything in an unbiased way. So I think, in general, it has those particular features that make it very competitive and make it differentiated. But certainly, if you have an existing fraud solution, this could augment it by giving you another read on fraud. You could essentially have your existing fraud solution and the recommendations from this solution, again, arbitrated at some level and take the combined answer as to what to do.
Thanks. Another question, can this solution access data stored in PDFs?
So it's a good question. So a lot of times police reports and other types of data are stored in PDF files. And if the PDF file is essentially a text PDF file, we can absolutely incorporate that directly. There's no need to translate that into another format. If the PDF file is a scanned image, then that particular file would have to be run through some type of OCR program, and we can help you work with a number of different vendors to locate the appropriate software to make that happen. We've had clients who have done it both ways, and we've been successful, so it's definitely doable.
Okay, great. I have one more question in the queue, so any other attendees who are looking to ask questions or haven't asked a question yet that would like to, please type them in now, because this is the last one that I have so far. And that one is, how does this solution evolve over time as fraud patterns change? Yeah, so that's a great question. One of the things about fraud is that it doesn't stand still, and the way that organized fraud in particular, and to some extent opportunistic fraud, work is that they figure out that they're being detected and they change their patterns. And one of the beauties of this process is that there's a high degree of automation, and we're constantly reevaluating the predictive models and the rules to determine whether they're still relevant. And if they become less effective, we use the most recent data and rebuild those predictive models so that we can then retrain the models on the new patterns for fraud. So it's not a static solution. The rules are not static. We constantly tweak those, and the models are actually automatically tweaked over time to make sure that they're relevant to the existing fraud patterns, the new and developing fraud patterns. Great question. Yeah, thanks. So at this snapshot in time, there are no other questions in the queue. Let me give everybody about 30 seconds to rethink that. While you're doing that, one thing I would add to the earlier question about the differentiator of the SPSS and QueBIT solution is that it really gives organizations the opportunity to operationalize the solution, to actually embed it in their process so nothing gets missed. Intuition, is taken out of the equation. If you already have fraud systems in place, it doesn't controvert them, but it can absolutely help identify activities that wouldn't have been identified normally, which really can translate into pretty high ROI, as we actually had the customer for whom the solution was centered around, as it actually played out for them. So something to keep in mind. So I see no more questions coming in. As promised, I would give time back if possible. That concludes our presentation. Thanks again for attending, and please feel free to email us with any additional questions that may come up, and Scott will answer them accordingly. If you're interested in a replay of today's presentation, please visit our LinkedIn site, our QueBIT LinkedIn site. We will be making it available. At QueBIT, what gets us out of bed in the morning is having the chance to help our customers get their businesses to perform better by enabling them to make more informed decisions faster. And we truly welcome the opportunity to do so with yours. Have a nice weekend, everybody.